Hello everyone, my name is Akanksha. I'm an assistant professor in the Department of Mathematics at Manipal Institute of Technology. In today's video, we are going to study topic digit sum, which is also known as digit root. And in this video, we are going to look at some basic concepts around digit sum, digit root, and some related problems. I must say, guys, this is a very interesting topic. You all will enjoy it. So let's get started with the basic definition. So what is mean by digit sum or digit rule? So as name suggests, digit sum. So when you see digit sum, what comes into your mind? So given a number, what is mean by digit sum? Can you guess, like plain guess? Yes, I think you all must have guessed it correct. So, digit sum or digit root of a non-negative integer is a single digit number or single digit value obtained by iterative process of summing the digits. Yes. So digit sum is nothing but you just have to keep on summing up the digits. Example. Let's see one example, one or two examples so that the concept would be clear. So digit sum of 1, 2, 3. So 1, 2, 3 is a number 123. So in short form, we generally write digit sum as DS. So DS of 123 is simply sum of the digits. What are the digits in this number? 1 plus 2 plus 3. 1 plus 2 is 3. 3 plus 3 is 6. So, digit sum of 123 is equal to 6. Is that clear? Let's consider one more example. So, second example is digit sum of 49. So, let me write it in short form. Digit sum of 49. Here, how many digits are there? Only two digits, 4 and 9. So digit sum of 49 is 4 plus 9. And 4 plus 9 is nothing but 13. But here, again, you have two digits in the number, right? But by definition, what is a digit sum or root? It is a single digit value. Okay. So since sum of 4 and 9 is again a number which has two digits, so what you can do? You have to add 1 plus 3 again, means sum of the digits of this number, this new number, and that will equal to 4. So, digit sum of 49 is 4. So always remember, digit sum of any non-negative integer is a single digit number. So first you have to add the digits in the given number. If you land up a single digit like this, that means that is the digit sum. And if your digit sum in first round has again more than one digit, you have to do the process again until you get a single digit by repeatedly doing this digit sum thing. Am I clear to everybody? So this is a iterative process. Okay. So digit sum is an iterative process of summing the digit until you get a single digit value. Okay. So here is a shortcut. So there is a shortcut to compute digit sum. What is the shortcut? So what you have to do is, given a number, like here 123 was a number, 49 was a number. So given a number, what you do, you just divide it by 9. Okay, please remember this shortcut. So if you have a big number, although this process itself is very simple, you just have to keep on summing, but still if you don't like it, there is one more method to compute a digit sum. So what you have to do, given a number, you have to divide that number by 9. Okay, so there could be two possibility. One, the number may be divisible by 9. So if that is the case, remainder will be 0. Okay. And second case is when the given number is not divisible by 9. If it is not divisible by 9, that means remainder will be non-zero. Okay. So what you have to do is, given a number, okay, for which you have to calculate your digit sum, what you do, you divide it by 9. So there could be two possibility. One is either remainder is 0, other thing is the remainder is non-zero. So if remainder is 0, digit sum is simply 9. Okay, is that clear? If remainder is 0, digit sum is simply 9. And if remainder is non-zero, digit sum is equal to that remainder itself. Let's check this. Okay, and digit sum of 0 is 0. So let's try to understand this. Let me try to uh, change the color if it is possible at all. So let me change the color of my markers so that, let me take this color. So, so let's see whether this shortcut is correct in the case of these two. So digit sum of 123. We have already seen that digit sum of 123 is 6. Let's check this using the shortcut method. So according to this shortcut, you have to divide 1, 2, 3 by 9, right? You have to divide it by 9. Just do it. So, so it is 1, it is 9. So remainder will be 3. Again, you just take this 3 down. It is 33. How many times you have to do it? So, uh, so 3 times, I guess. It is 27. And what is the remainder? Remainder is 4, right? No, no, sorry. Remainder is 6. Let me erase it. Remainder is 6 in this case, right? It is 6. And you know that if it is not completely divisible by 9, then remainder will be the digit sum. Here you can see that 6 digit sum is 6. So you can use any method. If you like, you can use this digit sum wala method, or you can use this shortcut. So according to this shortcut, what you have to do is you simply have to divide it by 9. Okay, this is not going. Let me erase this first so that it will be clear. Let me erase it. And then we will see how to do, how to compute digit sum of multiplication and other things. So digit sum, quick example. So again, we have already done the example. So digit sum of 1, 2, 3, you just divide 1, 2, 3 by 9. Remainder will be 6, and digit sum of 1, 2, 3 is 6. We have already seen that. Similarly, next example was 49. Let's see whether shortcut will work for 49 or not. So 49, you have to divide it by 9 according to the shortcut. Okay. So how many times you can do it? Yes. You just I hope you all know how to do this division. Divisibility and all we are done with. So I guess 4, not 4, it is 5. So it is 45. And what is the remainder? Remainder is 4, because 49 is not divisible by 9. So remainder is 4. So according to the shortcut, digit sum for 49 should be 4. And we have already seen it here. Digit sum of 49 is indeed 4, right? We have already seen that. So shortcut is working fine. Now let's see if remainder is 0, what will happen? So 18. So let's go through the digit sum wala process. So digit sum of 18 is 1, plus 8, and that is 9. So digit sum should be 9. Let's check according to the shortcut. So according to the shortcut, what you have to do, you have to divide 18 by 9. So how many times? 2 times. And remainder is 0 actually. So what is the rule? If remainder is 0, then digit sum is equal to 9. So in this case, for the case of 18, remainder is 0. So digit sum of any number is 9. One more thing you have to pay attention to, digit sum can only be 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If it is 10, digit sum is 10, so it becomes 1 because 1 plus 0 is 1. So there is no way that for one value there is only one number. Okay, so for certain non-negative integers, you may have same integer, you may have same digit sum. Okay, now properties. First property is addition. So if somebody asks you to compute digit sum of two integers, sum of two integers, so digit sum of a plus b, digit sum of a plus b is equal to digit sum of a plus digit sum of b. Okay, am I clear? So digit sum of a plus b is, you just compute first digit sum of this a number, digit sum of b, and then compute digit sum of both. Let's see this by an example. So example is 12 plus 36. You have to compute, let's say, let me write it clearly. So a is 12, let's say b is 34. Okay, am I clear? So let me take a as 12, b as 34. Now you have to compute digit sum of 12 plus 34. So one way of doing it is digit sum of 12 plus 34. Add them up. What will you get? You will get 46, right? 4 plus 2 is 6. 1 plus 3 is this. So digit sum of 46 is nothing but sum of the digits. You all know that. So it is 4 plus 6. 4 plus 6 is 10. But again, 10, again, it is a two-digit number. But digit sum is always a single digit. So you have to do digit sum again. And it is 1. So digit sum of 12 plus 34 is 1. So digit sum of 12 plus 34 is 1. Now this is one method. The other way around is you compute digit sum of 12. Digit sum of 12 is 1 plus 2 is 3. Then you compute digit sum of, so basically first you compute digit sum of A, then digit sum of B. Digit sum of B is, what is B? B is 34, right? What is digit sum of B? It is 3 plus 4. What is this? It is 7. Now, digit sum of A plus digit sum of B. What is digit sum of A? Digit sum of A is 3. Digit sum of B is 7. And digit sum of 3 plus 7 is digit sum of 10. Both are the same thing. It is 1 plus 0 is 1. You can see that digit sum of A plus B is same as digit sum of A plus digit sum of B ka whole digit sum. Am I clear? So what you do, if you want, you can compute it like this or you can compute it like this. Next property, subtraction. Subtraction again follow the same rule. So here you see digit sum of A minus B. How will you compute it? Either you first subtract A from B or B from A and then you compute digit sum, or compute digit sum of A, compute digit sum of B, subtract the digit sum of B from A and then compute digit sum. Both are the same thing. This is the rule we followed for sum also, addition also. So let us take one example here. A is 34, B is 12. So digit sum of A minus B is digit sum of 34 minus 12. 34 minus 12 is 4 minus 2 is 2. 3 minus 1 is 2. So it is digit sum of 22. But digit sum of 22 is nothing but 2 plus 2, that is 4. So digit sum of A minus B is 4. Let's see now digit sum of A. Digit sum of A is digit sum of 34 because A is 34 and that is 3 plus 4. 3 plus 4 is 7. Again compute digit sum of B, but B is 12. So digit sum of 12 is 1 plus 2, that is 3. Right? Now, oh, what happened? So now digit sum of A minus digit sum of B. What is this? This is digit sum of A is 7. Digit sum of B is 3. So subtract it. So it will get digit sum of 4. It is a single digit. So digit sum of any single digit is that digit itself. So it is 4. So you can see that it is the same. So subtraction, you can individually compute digit sum and then do the operation, or you'd first do the operation then compute digit sum. Does not matter. Now here is a special case. So for example, let's say you have to compute digit sum of minus number. So let me change a as a as 12. Okay, before it was 34, na? A as 12 and B as 34. Hmm? So digit sum of A minus B is digit sum of 12 minus 34, but that is digit sum of minus 22. Remember, you cannot compute digit sum of a negative number. So, not cannot be computed, right? Can't be computed, right? Because you cannot compute digit sum of a negative number. However, what you can do is, but you can use this rule. Still, you can use this rule. So, digit sum of 12 is 3. We have already computed. Digit sum of 34 means this is nothing but digit sum of A is 3. Digit sum of B is 7. So, now digit sum of A minus B. Digit sum of A minus B, it is 3 minus 7, that is digit sum of minus 4. But for single digit, you can do it. How will you do it? You just add 9 in that. Okay. This is again a trick. You have to remember it. Digit sum of 5 and that is equal to 5. So generally digit sum of any non-negative integer is not possible, but if your integer is of single digit, then you can do it by adding 9 in that. So you cannot compute digit sum for minus 22, but you can compute digit sum of minus 4, minus 3, minus 2. So let me give you one more example. So digit sum of minus 10 is not possible, but digit sum of minus 1 is digit sum of minus 1 plus 9 and it becomes 8. So please remember that. Now multiplication and division. Multiplication, same rule. So digit sum of A into B, where A and B both are non-negative integer, is same as digit sum of A multiplied by digit sum of B. Again, first you do multiplication and then compute digit sum, or you compute digit sum of individual numbers and then you do multiplication. Does not matter. So let us consider one more example here for multiplication. A is 12, B as 4. Okay, I can take it. Now compute digit sum of A into B. So that means digit sum of 12 into 4. What is 12 into 4? It is 48, right? 48. So what is digit sum of 48? Digit sum of 48 is 4 plus 8. But 4 plus 8 is how much? It is 12, right? It is again not a single digit number. So you have to compute digit sum again. So 1 plus 2, it is 3. Okay. So digit sum of A into B is 3. Am I clear? Now, this is one thing. Now, you compute digit sum of A first. A is 12. That is digit sum of 1, 2. 1 plus 2, it is 3. Now, digit sum of B. You can see one thing, digit sum of A into B and digit sum of A is equal, right? But it has nothing to do with any, you cannot generalize it. It is just by coincidence, as I told you. So for digit sum, you only have 10 options, 0 to 9 numbers. So there will be plenty of, infinitely many of non-negative integers. For them, digit sum are same. Okay. So digit sum of B is 4, right? What is digit sum of 4? It is a single digit number. It is 4 only, right? So now digit sum of A into digit sum of B. You can see the difference, no? First we have computed digit sum of A into B. Now we have changed numbers to it, their digit sum. So 4 into 3 is, it is 12, right? And what is digit sum of 12? It is 1 plus 2 and 3. So again, so either you do the operation first and then you compute the digit sum, or you first compute digit sum of the individual numbers and then you do operation and then compute digit sum, does not matter. And one more thing, there is no direct rule to compute division of two numbers. So means there is no rule for division of digit sum of A divided by B. No direct rule. Okay. So you can do addition, you can do subtraction, you can do multiplication, but we don't know how to do division of A divided by B. There is no such rule. So what you have to do is, given A and B, you have to divide them and then only you have to compute the digit sum. Now we will see certain examples. So all the concepts are clear. Now we are ready to apply those concepts to questions. So let's consider first example, first question. So what is the digit sum of this big number? How will you compute? Again, you have two choices. One is you add the digits and get the number, or you divide this number by 9, and if it is divisible by 9, then you are done. And if it is not divisible by 9, that means your remainder will be the digit sum. So if it is divisible by 9, digit sum would be 9 itself. Okay. But I personally feel that instead of dividing, it is easy, you follow the digit sum wala rule. So that I like more. So basically you have to compute digit sum of this number. So digit sum is sum of the digits. So digits are 9 plus 8 plus 7 plus 6 plus 5. That is equal to 35. Again, it is not single digit. So you have to do the digit sum again. So 3 plus 5 is 8. So digit sum of this big number is just 8. So option A is correct. Simple? Interesting? Okay. Next problem. So here, find the digit sum of 236 into 54. Now it is big multiplication, isn't it? So that is where you can apply this rule. So you can do this multiplication first and then digit sum, or you can compute digit sum first, then you multiply, because remember digit sum is single integer. So multiplying two single digit number is much more easier than multiplying these huge integers. So whenever you see these multiplication or multiplication of these huge numbers, or addition or subtraction of these huge number, so first you compute digit sum. So digit sum of 236 is 2 plus 3 plus 6, that is 11. Again, two digit number. So again you have to compute digit sum, that is 1 plus 1 is 2. So digit sum of 236 is 2. Digit sum of 54 is 9. Now digit sum of multiplication, we all know that digit sum of 236 into 54 is same as digit sum of 236 into digit sum of 54, right? But digit sum of 236 is nothing but 2. So that will give you, just you have to multiply 2 and 9. 2 and 9 is 18. Remember, 18 is divisible by 9, or simply 8 plus 1 is 9. So digit sum is 9. So your B option is correct. Am I clear? Where can you use such rules? These type of rules. When A and B are huge number, there you have to use them. Now, next problem. Next problem. Okay, third. Which number is divisible by 9? Now you have two options. First, these big numbers, you start dividing it by 9. And if remainder is 0, that means your number is divisible by 9. But here you can use digit sum. Remember the rule? If digit sum, if a number is divisible, so here is the rule. Let me write it. Rule. If number is divisible by 9, yes, then the digit sum of the number is 9, right? So if number is divisible by 9, that means the digit sum is 9. So we can use this statement. So that means if digit sum is 9, then number is divisible by 9, isn't it? So what is easier for you? Computing digit sum or dividing all these numbers by 9? For me personally, adding digits is much more convenient and easy. So let's start with the first one. So digit sum of A, that is 5, 1, 2, 3, 4. So it is 5 plus 1 plus 2 plus 3. 5 plus 1 is 6. 6 plus 2 is 8. 8 plus 3 is 11. Digit sum of 11 is 1 plus 1. Let me write it again. It is 11. But 11 is again double digit number. You have to compute digit sum again. It is 2. Not correct answer, because 2 cannot be divisible by 9. So digit sum of second option. Second option is 6, 7, 5, 8 and 4. That is 6 plus 7 plus 5 plus 4. Oh, sorry, 5 plus 8 plus 4. 8 plus 4. You have to add them up. So 6 plus 7 is 13. 13 plus 5 is 18. 18 plus 8 is, this we have to see. So 18 plus 8 is 26, right? 26 plus 4 is 30. Sorry, 30. So it is 30. Again, two digit number. I don't know why I'm writing 6 for 0. Okay. So it is again two digit number. 3 plus 0 is 3. Not correct, because we are looking for 9. Next option. Digit sum of 8, 9, 1, 2, 7. Let's check this one. 8 plus 9 plus 1 plus 2 plus 7. That is equal to 8 plus 9 is 17 plus 1 18, then 2 is 20, then 27. Okay. Again, you have to do this. It is 2 plus 7, and that is finally 9. So, this C is your correct option. So, option C is correct. So, am I clear ki how we have computed it? If you want to compute whether a big number is divisible by 9, you just compute the digit sum. If digit sum is equal to 9, that means number is divisible by 9. Okay? Next problem. What is digit sum of this minus digit sum of this? So again, what you can do is you subtract them. You have to subtract these two big number. So simply you just have to add the digits. So digit sum of 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Okay, huge. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, 21 plus 7 is 28, 28 plus 8 is, so this I have to write 28 and 8 becomes 36. Now 36 plus 9. So 36 plus 9 is 45. So again, you please check this calculation. It is 45, right? But 45 again, you have to compute the digit sum 4 plus 5, and that is 9. Okay. Next number. Digit sum of 9, 8, 7, 6, 5, 4, 3, 2, 1. Without computing the digit sum, can anyone guess what would be the answer? I'll give you few seconds to think about it. So how do we compute digit sum? Just try to think. So digit sum of any huge number is sum of the digits, right? So what are the digits of this number? 1, 2, 3, 4, 5, 6, 7, 8, 9. What are the digits in this number? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, but in reverse order. So it would be 45 again, because you sum the digits from here to here, from this direction to this direction, or from this direction to this direction. Both would be the same. So it is 4 plus 9, and that is again 9. So what would be the digit sum of 1, 2, 3, 4, 5, 6, 7, 8, 9 minus digit sum of 9, 8, 7, 6, 5, 4, 3, 2, 1. It is 9 minus 9, and that is equal to 0. So option A is correct. Is it okay? So compute the digit sum. One more thing you have learned. You just change the places of these numbers. Digit sum would be the same, right? So whether you write 1, 2, 3 first, then 7, 8, 9, means any permutation, any circulation of these numbers will give you same digit sum. Okay, what is the digit sum of this cute number 888? Simply, you just have to compute the sum of the digits. How many 8s are there? 1, 2, 3, 4, 5. And it is 8 plus 8 plus 8 plus 8 plus 8. So 8 plus 8 is 16. So you can just multiply them for 5 times. So 5 eights means 8 fives are, or 5 eights are 40. So it is 40. But again, it is two digit number. Again, you have to compute digit sum. So 4. Simple. A is your correct option. Next. So what is given in this problem? So digit sum of A. Digit sum of something is given to be 3. Digit sum of B is 5. Then which of the following could be digit sum of A cross B? How will you compute? Again, I will give you a few seconds to think about it. So here, you A into B, you have to compute, but A is not given. A is unknown. B is again unknown. How will you compute it? Do you remember the rule? Do you remember how will you compute? How do we compute digit sum of two integer? Let me remind you the rule. So digit sum of A cross B is, if you remember, digit sum of A into digit sum of B, right? So although A and B is not given, but that is not at all needed to compute A into B or to compute digit sum of A into B. But what is given? Digit sum of A is given, digit sum of B is given. So you can easily compute. So digit sum of A is 3, digit sum of B is 5. So digit sum of 3 into 5 is 15, isn't it? So that is 1 plus 5 is 6. So it is 6. Am I clear? So one way to compute digit sum of product of two number is first you compute the product and then do the digit sum. But in this case, A and B was not at all given. But what was given is digit sum of both numbers. And we already know that digit sum of A into B is same as digit sum of A into digit sum of B. And we have used simply the formula to compute digit sum of A into B. Next problem. Which of the following has a digit sum equal to 9? Okay. Again, you have two methods to do it. First is you compute digit sum and which all digit sum is equal to 9. All those options would be correct. Second option, you divide, you check which all are divisible by 9. So you have two options. So we are done with, okay, let's start. Which of the following has a digit sum equal to 9? What is your guess? Any guesses? So, if you remember, we have done this divisibility. If you remember, I gave you a shortcut how to check a given number is divisible by 9. If sum is divisible by 9, that means number is divisible by 9. But let it be. So, I will go with digit sum wala rule because that is more convenient. The chances of landing into a wrong answer is very less. So, let me start with option A. Digit sum of 720. It is 7 plus 2 plus 0. It is 9. Correct option. Digit sum of 315. It is 3 plus 1 plus 5. 3 plus 1 is 4. 4 plus 5 is 9. Correct option again. Digit sum of 450. It is 4 plus 5 plus 0. It is again 9. Good. Correct option. Digit sum of 261. And that is 2 plus 6 plus 1. 2 plus 6 is 8 plus 1. It is 9. So all options are correct actually. So if somebody asks you which of the following has digit sum equal to 9, you just have to add the digit sum and keep on adding, which all will give you 9. All those will have digit sum equal to 9. So all options are correct. Next problem. If digit sum of 1, 2, 3, 4, 5 is equal to 6, digit sum of 5, 4, 3, 2, 1 is 6. What would be digit sum of 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1? Okay, simply what you have to do? You just have to add them up. So, let me write again. Writing this number again and again will be difficult. Let us define A, let me give the name. A as 1, 2, 3, 4, 5. B as 5, 4, 3, 2, 1. Okay, A and B. Now, what is given? Digit sum of A is 6. Of course, it is 6. I think 1, 2, no, it is, I don't know. We have to check it. Digit sum of B is also 6, of course, because both have same digits, but in different order. We have already seen such question. If you change the order, digit sum does not change. So let me rewrite it. It seemed like 9. Okay. So you have to compute digit sum of A plus B. So one way is you have to add these two big number and then you have to compute digit sum. But that will be difficult because big numbers. But what is given? You are already given digit sum of A and digit sum of B. You know the rule of addition. It is simply first you compute the operation and then do the digit sum, or you first compute digit sum, add them, and then you compute digit sum again. So digit sum of A is 6, digit sum of B is again 6, and that is 12. So digit sum of 12 is 3. So which of the option is correct? This one is correct. Simple, no? Okay, next. Which number has digit sum 9? We are already done similar kind of problem. So 4 plus 3 plus 2. So A option is 4 plus 3 plus 2. 4 plus 3 is 7 plus 2 is 9. A option is correct. Now let's see B option. 7 plus 2 plus 9. 7 plus 2 is 9. 9 plus 9 is 18. Again, you have to do the digit something. It is 9, right? So B is again correct. I think in this question also all are correct. So 3 plus 6 is 9. Yes, correct. Fourth option. 2 plus 3 plus 4. 2 plus 3 is 5 plus 4 is 9. So in this case also all options are correct. But it may not always be the case, okay? Next, which of the following pairs have the same digit sum? So what you have to do is you have to compute digit sum of this, digit sum of this. If digit sum of first number and second number is the same, that means the pair has same digit number. What do you think? 1, 2, 3, 3, 2, 1. Whether it will have the same digit number? Think about it. I will give you few seconds to think about it. Yes. What do you think? Which of the following pairs have the same digit sum? What do you think about option A? Digit sum of 1, 2, 3 is 1 plus 2 plus 3, right? What about digit sum of 3 to 1? It is 3 plus 2 plus 1. Both are the same. So definitely A is correct. We don't know about B and okay, let's think about this one. 4, 5, 6. 4, 5, 6. Same numbers. That means digit sum would be the same. What about this 1, 1, 1, 2, 2, 2? This we have to see. 1 plus 1 plus 1 is 3. What about 2 plus 2 plus 2? 2 plus 2 plus 2 is 6. Not correct. What about 2, 3, 4 and 4, 3, 2? Yes. 2, 3, 4, 4, 3, 2. Both are the same. So, option A, B and D are correct. Is this okay? So here you don't need to compute, right? Even I can keep on increasing the pair. You don't need to compute it. If digits are the same, that means digit sum is going to be the same. Okay? Next question. Which of the following cannot have digit sum 9? Again, simply you just have to add the digit sum. 9 plus 0 is 9. Not correct. 8 plus 0 plus 1 is 9. Not correct. 1 plus 0 plus 8, same digits, is 9. Not correct. 1 plus 2 plus 3, it is 6. Correct. So which of the following cannot have digit sum 9? this, because digit sum of 1 plus 2 plus 3 is 6. Okay. Next, if the digit sum of a number is 9, okay, which of the following must be true? So if digit sum is 9, what can you say? Number will be divisible by 3. Number will be divisible by 9. Number ends in 9. Number is perfect square. You already know that. If a number is, I have given you the rule. I'm not going to write it again. So if number is divisible by 9, then digit sum is 9. Right? So if digit sum is 9, that means number is divisible by 9. So option B is correct. Remember, I gave you this rule in written. Let me go back to that slide. So if number is divisible by 9, then digit sum of the number is 9. Right? So if digit sum of number is 9, then number is divisible by 9. Okay? So what is given in this particular problem? In this particular problem, they have given is digit sum is 9. So which of the following is correct? Number is divisible by 9. Simple. Here are some practice problem for your reference. So what is the digit sum of this big number? What you have to do? You just have to add them up. 9 plus 8 plus 7 plus 6 plus 5. I hope you all know addition, right? So just add them. If you get two digit number, add the digits again. Okay? Because digit sum is always a single digit. Please remember this. Which number has digit sum 9? We have already done 2-3 questions on this. So you just have to add the digits, and those number which gives you digit sum 9 are your correct options. What is the digit sum of 1, 1, 1, 1, 1? So how many ones are there? 6. So it will be 6 only. Okay, simple. So digit sum of A is given to be 6. Digit sum of given B is given to be 6. What is the digit sum of A into B? Remember, A and B is not given, but digit sums are given. We have already done similar questions. So I hope you all are able to do these problems. Next, digit sum of 2024. Add them up, you will get the answer. Which of the following cannot have digit sum 9? We have solved similar question. What is the digit root? Okay, digit sum and root are the same thing. Digit sum is same as digit root. Don't get confused, okay? Means you have to add these nines. 5 nines means 45. So it will be 9 only. You know that it is divisible by 9. So sum will be 9. And that's all for today's lecture. I hope you enjoyed this topic, digit sum. It is the most simplest topic we have done in this course. And I really hope you get a lot of questions on digit sum in your CLAT exam. So yeah, see you in next lecture. Bye bye.